You'll be back on what?
Hey everybody, Tom here from Inspiration Metalworks, welcoming you to the Barzy Industrial Summer Bash. Hopefully you guys can see it now. If I can get some confirmation, that would be awesome. I'm just looking through and saw an ad on your TV. Sorry, Stephen. Yeah, so hopefully things are showing up. So the banner's showing up, so that's good. It looks like we got things working. So hopefully we got that. We did something different this year. Stan wanted us to break up the recording into 2-hour segments, right? So there will be a different link for each of the 2-hour segments. So you should be able to just stay on Stan's channel. If you're subscribed to his channel, you'll get alerts and things like that. But every 2 hours, we'll start up a new stream. So we're trying something a little different this year. I don't know how it's going to work because it's the first time we've done it. So please bear with me on that one. But right now things are going pretty well. I'm seeing some bandwidth issues for some reason, and I'm trying to figure out what's going on. It's the same setup that we had last year. You know, we optimized all the network, and I tell you, I spent the last 2 days trying to sort through that, and I'm still getting some bandwidth issues. So yeah, let me know how that's going. Keep me posted in the chat. We'll see how things are going. So yeah, let me know. Let me know about buffering and things like that too. So you're saying no sound, Dennis. You're saying no sound, but Steven's saying a bit of lag, and then I'm getting good sound from other people. So we'll see. I'm tweaking things a little bit as we go. So I do appreciate everyone giving some feedback, and I appreciate your patience. So where we're at right now, let's talk about it. If you don't recognize the location and that lovely sign from Miss Emma Ritson, I am in Stan's shop. Oh, you're putting it out? Okay. Thanks, Emma. Hey, so I don't know if you heard, we've got a new stream every 2 hours. Okay. I hope so. Okay. Thank you. Yeah, you want to get on? Let me say hi.
Hi.
Yeah. There you go. So, anyways, we're getting started. We've got a couple of views. Let me change view for you so you guys can see. All right. So this view is from my station here. So I'm over by the bandsaw. If you guys are familiar with his shop, I'm set up by the bandsaw. You can see where we're doing all the different challenges. So people are still getting registered right now, signing up for the events, things like that. So the challenges will happen over on that side. We will actually move around throughout the day. There's a lot of stuff still going on. People are still getting set up. And this is the live stream. Thanks, Phil. So, yeah, the funny part is everybody wants to be a comedian. But hey, come here.
What?
Say hi.
To who?
Everyone.
Everyone. Hey, morning, everybody.
Hang on. All right, there you go.
I'm in frame.
Well, that's the preview. That's what's going on.
Okay.
Yeah, we'll see how that works.
Check 1, check 2.
There's plenty of audio.
Oh yeah, they're getting
Yeah.
it. Okay, nice. How's everybody doing?
Looks like things are okay.
Can we? How many?
Adam's here.
Yeah. How many viewers you got? Are you broadcasting?
Yeah. So we're having some problems right now. Streaming, the network is still going, but we got about 87.
7 people waiting to see the stream?
No, it's on.
Oh, okay. It's just real choppy. Are you actually rolling it on another?
He's got it up over there as well. So there's a buffer, things like that.
Of course.
It's dropping frame rate.
Ooh.
Yeah. I don't understand it. I
It's
know.
right there. You want to reboot? You want to reboot the
you know
motor?
what I'm really tempted to do for some of this is hardwire in.
That'd be awesome. Well, see,
I can't walk around when I do that.
You can hardwire in right to that.
Yeah.
I got
But
two.
people are watching.
Okay.
So if you want to give a opener or something.
Well, yeah. Good morning, everybody. We're getting worked out with our live feed, so we're working on it. So it's good to see everyone, and I got to get down to registration. Actually, they're a little short-handed down there, and we're just getting started with getting the raffle going. So I need to get that a kick.
So, yeah.
Cool. Hi, Stan. Hi, Marty. Precision Machine Works. 8 guests.
Yeah. No, we're
Okay.
doing. There's a lot of stuff going.
All right. Okay, you guys enjoy the show. We're gonna keep working on our feed, and we'll see you in a little bit. Okay.
All right.
There's Comp.
Yep. Yeah, Colin's there. Yeah. All right. Excellent. So yeah, we're still getting things going. Thank you. So bandwidth is still an issue, and we're hardwired out to the shop, and I'm 10 feet from the Wi-Fi. I mean, there's just no reason for this. So we're working on it. Yeah. So what I'm going to do is I'm going to put the slate back up for a minute. We're going to change location. I'm going to take you around to different spots so you guys can get a view of what's happening here at the shop. So let me set back up, and I will be back in just a few minutes. All right, folks. So just to give you a quick view, we got the swap meet going on, and I'm having all kinds of network issues still.
Excuse me.
Still working on that. But yeah, so we got the swap meet going on. As you guys can see, lots of fun stuff here. A lot of really cool things. I'm going to brag a little bit because I got a shaper, and I've been looking for one for a while, and I managed to snag that yesterday actually, so before anybody even got here. But yeah, so hopefully things are going okay. All right, there we go. Good. So yeah, we're still gonna, I'm gonna set up, move around. Now, if I leave the camera going while I'm walking around, I just want to warn everybody, it's, not only is it really jittery, because I don't have this on a Steadicam, which is on a tripod, but it's possible that it's gonna buffer pretty bad because all the motion. So I'll see what I can do, but I will I'll take you on the tour. How's that sound? All right. So heading down the hill.
Hey, Tom.
Hey.
You're being filmed while you're filming me.
We're live streaming, buddy.
Well, hello. Hello, world.
Yeah.
Hello.
We
Mom,
got
Dad, look, I made it.
you got Scott Tyndall here. Hey, how are you?
Yeah.
All right.
They probably would have wanted
Hey.
that one.
Bo. Buddy, you're live. Tell you what. Come here. No, go back on the camera. Say hi. Say hi.
Hey,
So, who are you?
my name is Bo,
Yeah, and where are you from?
Florida.
And what's the channel that you're representing?
Do Right Fabrication.
Yeah. And who's your dad?
Jim Bollinger.
Yeah. So I'm guessing everybody knows who that is, huh? But thought we'd say hi. All right. Okay, we'll see you a little bit later. All right. So, as you can see, things are a little on the crazy side here. Still setting up. A lot of folks still showing up. I'm gonna try and make our way by.
Buying raffle tickets. I don't know if you know exactly what you're getting. So when you first walked in, there are several tables laid out, and these are going to be part of the raffle. We actually just got some new product in. I see some Makita stuff over there. I see some drill indexes. We also have Edge Technology, which you haven't seen Edge Technology yet.
We're gonna move.
You need to check out these products. They are amazing and incredibly useful. I've got several of
So,
them.
as you can tell,
ZP Fab is also
there's a lot going on, and I can't even get through there. So, I will have to wait a little bit. Oh, sorry, guys.
No problem. We're not hurrying to get anywhere.
Hey, wanna say hi real quick?
Hey, everybody. What's happening today?
There you go. How's that? So, who are you?
I'm Gary Snood from Longview, Texas, and it's my third year here. One of the guest hosts. My YouTube channel is Tools for Machines, and appreciate everything that Stan does for us in the YouTube community. He puts a lot of effort each year into this event, and I don't know if everyone understands how we do this, but the YouTube people like me come and help Stan out as much as we can. We try and show up a day or two early and help get the event together, and then it's a great day today when everybody shows up. All the guests are here, and we have all the raffle prizes, giveaways, have awesome sponsors that provide the raffle gifts and other prizes. So if you haven't been, I encourage everybody to try and get out here. It's an amazing event to attend every year.
Excellent. Well, I won't hold you up anymore.
All right.
Thanks. All right, folks. Let's head back and see if we can figure a couple of these things out. You know, it's the challenge. We run all these tests. Oh, hey. How's it going, guys?
How are you?
All right. Yeah, we run all these tests, and then the day of, everything just goes crazy. Like it didn't, like we actually hadn't done any of it. So, let's see what we can figure out, folks.
Your own laundry is what you're telling me.
Let's see what we can figure out. figure out why our network is having some problems. All right.
So it looks like a no Keith year. Is that?
I'm doing the live stream right now, sir. No, that's good. Yeah, so Keith's not here this year. Neither Keith nor Adam are here, but they are. So Adam's on the live stream.
Oh, wonderful.
He was, watching. So yeah, both of them had some medical stuff happen this past year, and so they weren't able to attend. But everybody was, they were all saying hi, and
Oh, excellent.
yep. Okay, so let's see. Is AV? No. All right, down to about 2 frame rates or frames per second. Okay, hey, just want. All right, guys. So we're still working it out. I am seeing a little bit. Hey, Chris.
Yeah.
Can you get is your audio? Is that you or is that?
So I've got a special announcement.
Is that some? Oh, it must be somebody outside that I'm hearing. Okay, never mind. Hey, I'm gonna try something, guys. So I've got a video that I'd like to put in. It'll give me a chance to work on some of these issues here. So give me just a second. I'm gonna change you over to video for a minute, and we'll see how that goes. So let's try that out. Okay, so apparently the video is just trying to make me look like a fool, so it worked. Sorry folks, I don't know what's going on, I'll be honest with you. I'm juggling, and it's just, it's crazy today. So let me see what I can do. I don't know what's happening here, but I'm working on it. Yeah, so let me see if I can get a little bit better performance, and I'll be back in just a minute. I may end up just hardwiring, so which means maybe not walking around like I had been. We'll see. All right, thanks folks, appreciate it. Colin.
Are we having fun yet?
No.
No.
Hey everyone, just a heads up. We're going to reboot the cable modem and see if we can get things started. So the stream may stop, or it's going to stop, and I'll have to restart it. But just stay here. We'll be back shortly. So sorry about this. Again, I'm not sure why we're having the problems we're having, but we're working on it. Sorry. All right. Let's see how things are going here, folks.
So I buy this knife, and it's like got this like
Trying to figure out how it's going.
I put it in my pocket, and I go. I stop.
Let's see.
I stop at Best Buy. I go to put my hand in my pocket, and it's open. Cut my finger. So I'm like,
So
I'm like, all right, well, let's take it. And I turn it out.
let's see how this is going.
I snap it on. I walk, and it flips open. And I'm
If I
like,
can get some feedback on how things sound. What I'm seeing on my side is
I'm like, this is a piece of shit. I'm like, give me this
adjusted
$3
frame
knife.
rates because of
I've got
bandwidth.
$25 on this piece of crap. Are you live?
Yeah, I'm live right now. Off this camera. There you go.
Yes, you did. Yeah, 2 years ago, right? Yeah.
Might be a little hot. I'm going to adjust audio a little bit too.
Yeah.
Yeah. Oh, you know what? Let me. All right. I know what the problem is. All right, folks. I think I figured out the problem. The system automatically adjusted size and frame rate on me. Let's check this now. All right, guys. Let me know how this is looking on this one. I just changed a few things around, and my guess is it really should make a difference.
You're coming home to me. You just don't know that yet. Hold on.
All right, we'll see how it's going.
All right, that's it. You're going home. Put you in the back of the room.
All right, so let's see how that's working.
I would say there was something that you definitely have to.
All right, it's not too bad.
What's the purpose of the double handle? Other than it's just so you get in your hand. No, just so that you.
Let's swing this camera around for a second. Hey, all right. So let's see how this is working. I'm not sure why, but today when I plugged the camera in, it saw it as a new device and it defaulted to 1080p 60. So that's why our bandwidth was going nuts. So bringing it back down to something reasonable. Hopefully this is helping. I know there's a buffer for a little bit, so I'm not sure when you guys will actually see this, but just trying to see how things are going. I've been watching the chat. There's a delay. There's probably 30 seconds to a minute of delay because it's doing buffering. So I'm trying to figure out how are things looking for you guys, where you're at in the stream and things like that. So basically I'm stalling for a little bit, trying to figure out what's going on and give you guys a chance to give me some feedback. Cape Cod CNC, low frame rate. Yeah, let me know about how low is it, because it is at 15 frames a second. We set it to 15 frames a second, but I'm seeing that it's being reduced even more down to 7.5. So I don't understand why. This is driving me nuts. It says due to low internet bandwidth, but no one else is on the network. So, all right, hang on just a second. I'm gonna give you a different view, and I'm gonna mute the audio for a second. Sorry, I'll get audio back on. So.
I remember.
Hey, good. How are you? All right. Hey, folks, I'm going to make some changes again. So I'm gonna turn the camera off while I reset, so it's not so jerky on you guys. But Give me just a second. All right, so that'll give a little bit of a better view of what's happening. I'm going to put you on just some basic audio while I run around for a minute. So give me just a second. I'm going to change that over now, and then so it's liable just to be, a lot of background noise for a little bit.
Oh,
Actually, that's what he always says. Yeah, I know. See the later things are going. Over here. Yeah, just so you know. You know, Bruce with me. Didn't shove it in your waist. In the U.S. Did that boot work? Want to reboot this?
Already did it. Thanks.
You saw I rebooted it like 10 minutes ago, right? So are we dead on our feet?
No, it's just chopping. Okay. It's clear, audio is okay.
They're not finished. That cookie tray right down there? Yeah. That's what they look like. They're not done now.
So I've got right now the new
Thank you for that's yours, huh?
Robin's such a great time. Really? Tell me you're not thinking about this.
I'll be right now. There you go.
Trying to fix that. No, I'm going to go live in 7.5 minutes. Good enough? Yeah.
What is this?
This court? Yeah. This is going across here in my extension.
Okay, guys, we're going to talk about number one of the competition. I got to say, I think it's fun.
This is going across my camera.
Sorry, I was looking at the
Oh, and this is my laptop.
the TV next to me.
Why is somebody hardwired in? Oh, just because you saw the attachment. I crossed when I was facing it down. I went down that way. You went yours. What are you doing?
Competition up there. It's about
Right. No, I'm just trying to sort out why.
So basically, you're going to run a flow through
5 mechanisms. I ran test after test after test for 5 and I'm struggling with this right now.
How can you and me being on the network plus?
It's not.
Is there anybody else on?
There's so much interference going on with everybody's.
Out to play title team.
I can give you a shirt. All right. These ones are charities. Oh, besides you.
Yeah, no.
Extra large?
I don't know, sign up.
Yeah. Are you extra large? No,
I'm
Yes.
all right, cool.
We're almost ready to start the raffle here, but I'm going to wait until a little bit after 9 o'clock because
I told him, I said, as soon as I get the live announcement of this, then I'm going to send him around to everybody and
watch it on Facebook. Or you can go up there and get to it in person. So, after that, we're going to start the raffle. Jennifer has already been testing on the raffle machine here, which is very unique screen. And I was going to say, he built something cool, and he did, but he also built something cool. That's great. So, make sure you're buying tickets. You can also buy tickets throughout the day, but we'll keep taking them in the machine.
once I get done announcing it, I want to grab the camera right away, bring it over here and do a close up with it. No, we didn't do that. We were going to, and I was like, well, it's going to be white out, so it's not like I'm going to do anything unless I take it down. Stan was disappointed, he wanted disco lights and stuff.
Disco ball.
Yeah.
Everybody likes it.
Okay, so take care of my lady here. I was just waiting for you to show up so we can get alone. That's beautiful, isn't it?
Tom, you got video going now? You got video going now?
All day. 8 hours.
Right.
If you want to stand over here, and if anybody does comment or anything, if you have just great responses. Yeah. So like this is really cool. I didn't set up anything, but you can set up an agenda. Well, yeah, you can just have it right here, but right here, it's a nice way you can set up an agenda, and you can be like, you know, you can add a whole list of stuff, and then you can bring up something here, and be like, yeah, like I should do.
No, you're standing in front of us. Check down there.
That's messing with I got 18 inches here. Yeah, you got but it has a super short bed. You run really quick. When you put a 3-inch boring bar in it,
I work on things this scale. I have different equipment for that.
Okay, can I get closer? Okay, let me take it. My tool post is on a riser. When you fresh
Yeah, I know they have the one. I got some warnings for you. If anybody needs to go back to the I get that down. A little bit different. So you can come up and see me. I've got my phone number.
You know what I don't have? I'm ready to get stamped. Yeah. I'm ready to get stamped. Yeah, Cat 5 years ago.
50 seconds. Why you shut it down?
Which one do I use? I only have you got the extra? You're using the USB.
Yeah, you're raising thank you so much for bringing a few plates. Thank you throughout the day.
Who else is going to have a USB hub? No, you need it for your stuff.
I don't have another one.
What do you need?
USB hub?
Can you just go into that one right there? Oh.
Really?
All right.
I love you, man, but really?
I'm broadcasting.
You're going live now.
4 seconds.
Yeah.
Well,
Are these separate raffles?
hey folks, we're getting ready to do live
Good
stream.
morning, everybody. Chris from American Rotary, and we are live from the Varsity Bash 2018. We're really excited to be part of this event again this year, headlining as the main sponsor of this event. But what we're even more excited about is that we're going to be launching the AMP. Hold on, let me get mic'd up here. We're launching the AMP, which is our newest product line. It's in the AMP series. It's going to be our mobile series phase converter. So we're going to pull this back. Get rid of this. So this is the AMP. It's going to come standard with 1 breaker and 1 outlet. You can add up to 2 breakers and 2 outlets. It's got the casters on it, locking casters. It's got knockouts on the side here for any type of expansion you want to do. It's going to come standard with a 6-foot cord and a 50 amp plug. It comes in 5, 10, and 20 horsepower. Let's just power it on so you can see how loud it is not. We've got a cable cord here so you can roll up your cable. You can get this cable in a 12-foot and 24-foot length as well. Again, there's other laser knockouts on the side here, so you're able to hard line in if you want. Top is easily removable by 4 bolts. There's a lifting hook underneath the cover. You also have a through rod here for lifting. It's perfectly balanced, so when you lift it, it'll lift straight up and down. It's not going to get all callywampas. We've also got caps that are removable here for easy access to the grease zerks inside the idler. It's all self-venting, so you don't have to worry about the heat. There's enough distance that you can wheel this in somewhere, and you can basically roll it around your whole shop and plug it in. Some of the key features of this are going to allow you to not have to pay those high install costs from electricians. So you don't have to bring somebody in and have them set up your shop. You can just roll this around from machine to machine and be able to have 3-phase power wherever you are in your shop. You guys have any questions on this at all? This is a 10 horse. 5 horse, 10 horse, and 20 horse.
Are they all the same size?
Yes, the footprint is the same on all of them.
I'm putting you on the spot.
What's up?
I'm getting the decibel meter out. Okay, I'm right next to it. Right next to it, it's at 82, 83, right?
So
but
6 feet is about the...
All right, so I don't know if I'm still on the camera or not. Right now, with background noise and everything, we're 78.
So all of our units are under 60 decibels, so we do have a class going on over here, and
yeah, right now we're actually every time I talk it throws it off. We're 66. And average right now, because peak was up a little higher. Average is saying about 77 for the whole room right now. So yeah.
Excellent. Well, these are available starting today for pre-order sales. They will ship by August 15th is the target date. And we're super excited about this product. It's been 2 years in design, and we've worked really hard at American Rotary on it. So we're really happy to offer this up to you guys. We actually reached out to the YouTube community about 2 years ago and said, if there's anything you guys wanted in a face cover, what would it be? And I got, of course, a laundry list. So I took it and I pretty much put everything into it. So at American Rotary, we have a great team that worked really hard on designing this, and everybody there, from our manufacturing to our office staff, they all had input, and it was really a team effort. So.
Hey, 2 things. So folks online are asking about expected pricing, and then for whatever reason, when you turn that on, bandwidth got better and frame rate improved.
Well, there we go. So we'll just leave this running all day. So we're running the broadcast off of the amp.
Like everything is better since you turned that on.
Oh, excellent. So price points, yeah, there's going to be 3 different price points. The entry level, so like I said, this comes standard with the 1 breaker and the 1 outlet. On the 5 horse, it'll come with a 10 amp. On the 10 horse, it'll come standard with a 20 amp. And on the 20 horse, it'll come standard with a 30 amp. But you can also add these in for an additional upgrade price, as well as the longer cord. So the price point on these is going to be, I'm trying to remember here, $11.99 on the 5 horse, $16.99 on the 10 horse, and $21.99 on the 20 horse. So, people look at that and they say, okay, well, that's pretty reasonable, we think, due to the install cost that you're going to save. On average, it's going to cost you $750 for an electrician to install just the basic install. So you're going to see about a $300 to $400 savings just eliminating that. So.
What's the input power?
On this one, it just depends on the unit. So right now we've got, so it's going to come standard with a 50 amp plug. So the 5, you can feed it, 20 amps. The 10, and it's all going to be dependent on what you're running off of it too. So, as low as 20 amps and up to, 80 technically on the 20, but then you'd have to get a pin and sleeve and stuff like that. So we're not offering the pin and sleeve right now just because of the price point of a pin and sleeve. So it's something that somebody wants to add later on down the road, they can definitely do so.
Curious, what's it like?
This one right here, I think it comes in at about 132 pounds. I mean, I could pick it up and take it off of there. Ray helped me, but I could have done it myself. Oh, all right, so Tom helped me.
Yeah, no, yeah. It's just that you and I moved that by ourselves, me with titanium in my back.
Right. Well, and Andrew helped me get it off the truck on the skid.
Yeah.
So, I mean, it's not that bad. So.
And you're not turning that off. Everything went perfect.
Oh, well, great. All right, well, it's a multi-purpose.
Put one of those in Washington then and see if that works.
Yeah, right.
So you got to keep that running the rest of the day.
That's fine.
I'm not kidding.
All right. So, anybody else have any questions at all? Yeah.
That's running, right?
That's running.
20, is it much louder than that?
No, it's not going to be much louder than that at all. It'll probably be about equal to that. And in fact, the whole noise that we get out of here is really, ideally, the fact that it's sitting on casters and you get a little bit of a hum from the enclosure. That's where you're getting the most sound from, because, with the 5 horsepower and the 10 horsepower, most of the time, people can't even tell they're running. They got to put their hand on it to tell it's running. So, but we're up off the ground. We're on a metal table. We're, you know, there's a couple variables, but you put it on the ground, it's even quieter. What's that?
Waterproof version?
We do. It's called the AI. The AI unit is our industrial unit, and that's the one that the online registration for that contest closed at midnight last night, and we'll be giving that one away this afternoon. So. Any other questions? Nobody asked me what AMP stood for, so that I was waiting for that one. So nobody had that question, but it does stand for something. It's, you know, American Rotary Mobile Phase Converter is basically what it is. Came up with that after we came up with the name, but or always more power is what somebody else said. So, all right, guys. Well, thanks for coming over, and you guys, thanks for watching. And we'll be back with you throughout the bash today live. We're gonna go check out Jim Bollinger and his class and bring that to you guys live, and we'll be visiting with all the other guys today. So, talk to you guys later. Have a great day. I have flyers here too if you guys want one.
Which one are you giving away?
This one. This is the one that's the $20 card, and then we have the
Yeah,
that's 10 horsepower.
Yeah, you and me both, bro. I'll look online. But,
All right.
I really like that. Thank you very much. I have questions about, you know, I'm looking more for energy efficiency and whatever. I'm using a homemade.
Yeah, so this are 98% efficient. It uses about 4 amps at idle.
Okay, that's one of the, that's one of the things I was wondering about. You know.
No, I know you're getting ready to have private conversations with people, so I want to make sure you're not mic'd up. All right, folks, hang on a second. We're still getting reconfigured, but. I don't know yet. Okay. Oddly, like I said, turning the phase converter on fixed all the network issues. So I'm sitting here like, I don't know. I'm actually going to walk around. I'm going to do some experiments first and see, yeah, with it running and see what we're doing. All right, folks. No, Colin, I'm not turning it off because I want it good. So actually, what we think it is. I was talking to Dan here, and what we think it is one big change. Let me see if you can see it in the. Yeah, you guys can kind of see it in the upper right. I forgot, since last year, Stan added solar panels, and that's a big inverter in the right. And it's a good possibility that that was causing some of our problems. So the phase converter running is like cleaning up the power for real. So we're gonna go walk around a little bit and see what's happening, because I tell you what, this is like really, really clean now. Whatever was the problem seems to be resolved. So, hey, Phil, you want to be on camera?
No, I'm good.
Oh, you sure? All right. So yeah, I'm gonna walk around a minute. Let me get a couple of things set up. Again, yeah, I know, not exactly ideal with that, but okay. That still looks good. All right, folks, you ready to go on walkabout? Yeah, okay. So, give me just a minute. I'm gonna, hang on, let's do this so you guys can see me. Okay, I gotta get this camera down off of here, and then we'll walk around and I'll show you a little bit, and we'll see if we're maintaining the connectivity that we've got now, and we'll see how that works. So hopefully this is in good shape. Oh wait, here we're twisted up on, yep, thank you. It's because I threatened to hook up the hardwire. Okay. So if things were gonna start to get crazy, now would be the time. So let's see. It seems to be, that's hilarious. Thanks. That's good. All right, you guys ready? Let me look at the chat for a second here. AVE is not here. He was not here yesterday either. Jorge, you're here. All right, awesome. So yeah, I do have audio on, right? Just making sure I'm not muted. Yeah, that's good. Okay, let's flip the camera around. And you guys ready? Let's go on walkabout and see how things work. So I'm gonna take you through. Let's start with what's happening in here. Oh, hey Chris, I'm kicking your camera again. Let's take a look at what's going on here.
Yeah, I've already requested it. Oh, he's just waiting. I've been waiting for months. So the views that you get now
Yeah, Ronald Reagan for president. Or Randy Richard, not in his shop, but in a shop. All right. Excellent. All right, so we're gonna go for a little walk. So we've got things that are happening here. Hey, you good? There's,
What do you need? I'm getting ready to start.
your feed didn't go? Because our feed went great. Oh, all right.
I just stabbed myself again.
Oh, that knife. Okay. Hey guys, I got to. So we're going to walkabout. Are you done with your class? Or are you
Getting ready to start in about
getting ready? Let's go watch class.
Do it about 5 minutes.
In about 5 minutes. Okay, we're gonna walk around first. We're testing out the updated live stream. Phil, you're on camera. You gotta say hi now, buddy. Dude, Phil is a workhorse. I mean, you would be amazing. Oh, we got a couple people here. But yeah, I mean, he did so much of the setup here. Oh, say hi, guys. Craig, Justin, Emma.
So we got our Wi-Fi okay?
Yeah, mostly. This is the stressor. Believe it or not, when we turned on the phase converter, whatever interference was causing problems went away. So I told him he can't turn that thing off. Yeah. So we're gonna stress it. Yeah, I know.
So hey, that's a new selling point for American Rotary, right? Yeah, no doubt.
Yeah. Run our
phase converters improve your Wi-Fi signal. Huh?
Exactly. All right.
Right on.
All right, we'll be back. Sorry. Rance, good to see you. Sorry, we're doing a little tour real quick of yeah, and it seems to be working okay. All right, so this is the classroom. Let's give it a second to adjust. You can see that's going to be starting in about 5 minutes or so. So, as you guys heard from Jim, nothing like dangling or a laptop on one arm, walking around. All right. So this is the other side of the swap meet that I tried to show you guys earlier. So we've got the swap meet. No, I'm not actually taking orders. Sorry, folks. What's that machine? Oh, Marty, I missed when you said that. Sorry. Yeah, everybody gets shy when you're right. How's the audio? Just trying to see how that's going. So, oh, Kevin. Excellent. All right. So we're going to continue our walkabout. I think I'm going to cut through this way. Oh, excuse me. Sorry. All right. There are quite a few really good stuff. Oh, I'm by the PA. Sorry. All right, it's gonna get bright for a second. All right, guys, say hi. Tara, say hi. All right, class has started. Yeah, we'll be right there. Okay.
I'm sure you'll have an answer for everything. You'll be able to ask questions.
How's it looking, folks?
Jason over
I'm not watching chat right now. Sorry. What I'm watching is our network and what's actually coming out.
So, are we ready? Gosh, we still got more tickets coming in here.
Yeah, looks like it's
we got no little
still doing okay
during the raffle because we didn't have a proper tourney thing
Here we go.
Stir up the tickets. James Green built a special for us this year. It's very cool. It's just going to be running. All right. Hopefully it's not going to turn out. If you see any smoke, let me know, so we'll turn it off. But I think it'll make it. So we've made this as random as possible. The other thing is it's going to get stirred up really great. Okay, Jan, you're putting in some of the last tickets now.
How you doing?
Okay, not that you can't put in more tickets.
Hey, I'll definitely catch up with you in a little bit if you got some time.
All right,
awesome.
About 30 seconds. Or not auction.
But that's okay.
Yeah, you guys know.
Okay, so guys, let's take a look at all the fun stuff that we're giving away here. I don't know how well you guys can see any of this stuff, but I'm on the far side of the property and it seems to be working all right. So yeah, still good. Yeah, you guys saw it. So yeah, unlike the AVE thing last year where everybody was speculating. By the way, everyone thought that Aaron Durda was AVE last year. That is Aaron Durda. He does have a YouTube channel and we will be promoting him soon. Actually, once we can convince him to start, you know, putting some content up. But yeah, so this is about as far away as we need to get, and I'm still seeing good network. That's awesome. So whatever was causing the problems is resolved.
Make sure that you get your items, so you don't have to worry about it. Go up and join Jim's class. Jim's got Jim Bollinger.
Okay, I'm gonna go get up to the TIG class so you guys can see that.
Functions of it. You need to head up there right now. It is a fantastic class.
Excuse me, gentlemen.
Jim teaches for Lincoln Electric, and Lincoln Electric is also a sponsor of the Summer Bash, and you can see a lot of the great products there.
All right, so Aaron. Hi, this is Aaron Durda, not AVE, guys.
Really exciting.
You're spoiling it, man.
Okay, we're going to put these last tickets in. We're going to let this thing spin.
All right, we're going to go up. Dude, having the phase converter on fixed our network. I tell you, things I never thought I would say. EJ, this guy is responsible for fixing all of our audio problems. So everybody say thank you. Yeah, but you fixed all the problems.
Thanks for doing.
Thank you. Excuse me. Time for a class. All right. Hey guys. Hey. All right, I'm going to change microphones, guys. Hang on.
You're live. Okie dokie. Okay. Hello, everybody. No, I want you sitting over there, okay?
Hey, where do you anticipate walking around?
This area, like here, and then out.
Okay, your frame is from where you're at right now to the front of the...
So if I come up here, are we good? So you're good here? How about here if I stand and talk to these gentlemen? Everybody's good? Okay, 1, 2, 1, 2, good? All right. How about in the back? Too loud? Too loud? Good, good, good. Can you guys hear me back there? Good? Audio. 1, 2, 1, 2, 1, 2. Did everybody get a handout? No, you didn't. Give me just a second when Bo gets back in here and I'll have him give handouts. If you guys are getting real tired in the back standing, because we have so many people that have interest, I'll do this again this afternoon. Okay? So that not everybody has to stand here, because I know your dogs are going to start howling about noontime and you're going to say, man, I wish I didn't stand up and listen to him babble on about TIG welding for 2 hours. So because so many people want to hear it, I'm happy to give it to you. Don't stand up there and be miserable. If you want to go do something else, we'll do it again. And those that decide to stay, I'll get you some lit here in just a second. Hey, Bo. you guys put that seed down and pass out to anybody. Whoever didn't get literature that would like a literature bag, please raise your hand so Bo can hand it to you. It's right there. So I'll start off telling everybody thanks for coming to the Bar Z this year. Thanks to American Rotary for sponsoring this for us. Without sponsors like American Rotary, this wouldn't be possible, and I mean that literally, because my buddy Chris Feeble standing there, and a lot of this is from you. Also, when you see Stan, be sure to thank him. This is Stan's house. You guys think about that for a minute. Would you let all these people at your house?
Who else needs them?
Because we now know we're machinists and metal workers. We're all about half crazy anyway. Yeah, so he understands our craziness, right? So be sure to go by and thank Stan for putting this on. He works about half a year to put this on to make this possible. It's a lot of work. There's some more in the back. So first, let me introduce myself for those of you that do not know who I am. My name is Jim Bollinger. I have a YouTube channel called Do Right Fabrication, where I do all kinds of stuff, some machining, welding, family stuff. It's all family friendly for the most part. I wouldn't be embarrassed to let your 9-year-old watch it, right? So if you haven't caught on, this is the mini-me. This is one of my 3. This is Bo. He's my son. Bo got the AB honor roll again this year, so he got himself a trip to the Bar Z Bash again. So it gets to be some really expensive A's and B's, if you follow what I'm saying. But he did really good. He pulled it off this year. I'm proud of him, so he's going to be my helper. Let me give you a little background about myself. I am not a professional welder for a living. A lot of people are like, what? I teach for Lincoln Electric a couple times a year. I teach this class along with some others in the industry. I've been doing it for about 10 years now. My full-time profession is a firefighter paramedic for the city of Orlando. I'm an engineer. I drive the fire truck. Been doing it for 27 years now. I can't wait to retire. How many people are in that category? Yeah, counting the days off the calendar. So you ask yourself, well, why is there a fireman up here teaching me welding? Well, when I started off welding, wanting to learn to weld, I learned at about 12 or 13 years old to stick weld. There was nothing out there in the world to teach me to weld other than some kind-hearted people that wanted to teach me. And let's be real honest about learning the trades. If there isn't that old crusty guy at the back of the shop that's willing to bring you in and teach you, the only thing there was back then, there was no YouTube, there was no social media, there was nothing to teach us. The only thing in the world were those big trade manuals, and what 13-year-old kid's gonna read a trades manual? The only thing you use that for is, you know, standing up to get something off the top shelf of, you know, right? So that's why we started this, to pass it on to your younger generation. I feel like that is so important. We're missing out hugely in this country by not passing the trades on. So I teach this class for Lincoln Electric. They're very kind and supporting us with all the literature that you see. Those that do not, there we go. I'm not used to using this, by the way. This is new for me. This is very new for me. Those that do not watch the channel, please go and subscribe. Also, the other YouTubers here, I will tell you this. If you like the videos you see us do, a lot of people don't know YouTube etiquette. It's never been taught. There's no class for it. That subscription down at the bottom helps us out immensely. You think we make money doing this? We don't. I actually have to put money into my channel to keep the channel running. I like teaching. I like being with this group of type of people. We don't make a lot of money doing this. We do this for the love of doing it. That subscription helps the channel support itself. Also, comment. If you see something you like, comment. Hey, nice job, thanks. That encouragement means a lot to all of us that are doing it here. That commercial in the front that everybody clicks skip, realize that's the only revenue that YouTube video that you're watching, that's the only revenue it creates. If you skip it, guess what else you skipped? The 4 cents that I made watching that commercial. So go make yourself a cup of coffee while the commercial plays, please. Thanks for all the support. If you have something constructive to say, there's so many people out here in our YouTube community that has a ton of knowledge. Just be constructive about it. Be supportive of us. Realize we're just a person. We're just making this video. Now let's start talking about TIG welding. If you guys, Andrew Padaka, your microphone is not working. We're good. Nobody cares about anything but the live stream. See this right here? This is compliments of your friends over at Lincoln Electric. There's a pin in there. I'm going to give you some information in this that is not in the handout. So if you want to write it down, it's a pin. Otherwise, take the pin home with you. It's actually a pretty nice pin. How many people in here already are welders of some form or fashion? Stick, TIG, MIG, gas? How many people in here on a regular basis attempt to be a welder? That'd be me. I'm going to tell you guys this. I have had the blessing in my life to work around or beside and be mentored by some of the smartest people in the welding world that I know of. And for 10 years, I've been able to glean knowledge. I am not an expert, but I have been able to learn from some of the experts, and it has been amazing. So I want to pass that information on to you. We'll start for a minute about safety. We'll move on. How many people in here weld with a welding helmet, auto darkening welding helmet? Wow, about half, more than half of you. How many people bought their Harbor Freight welding helmet for $29.95? Raise your hand. This is real quick. I'm going to tell you why I think that's a bad idea. This is my personal opinion, not endorsed by anybody else. How do you think they got that $29.95 helmet minus a 10% off coupon? How do you think they made it that inexpensive? It's a copy of somebody else's proprietary information. It was copied and it was manufactured in mass and not tested. Their helmets are not tested, they're not rated, and I cannot guarantee they will protect your eyes. For those of you that do not realize this, welding of all forms of arc welding produce light radiation. It will burn you badly, like a bad sunburn, okay? If it burns your skin, it will also burn the surface of your eye. How many people in here have been welders flashed before? Wow. For those of you who have not been welders flashed, let me explain what that is. That is the cornea of your eye getting a sunburn on it. You'll wake up about 1:30 to 3 o'clock in the morning and feel like somebody is holding your eyelid open and pouring beach sand in your eye. There is nothing you can do to make it feel any better. Believe it or not, as a fireman, I just ran that call the other day. Guy woke up in the middle of the night, thought he was dying. I'm like, I was welding all day. The next 8 hours are going to be rough for you, pal. Luckily, our eye heals very fast, it goes away. But realize when we do that over and over, we create scars. So the point of me bringing this up is I want you guys to use good helmets. Lincoln makes good helmets. There are a lot of other companies that make good helmets. Spleeglass, Optrel, Jackson. All of that stuff is tested and rated through a vetting process to make sure it meets industry standard. Please make sure you're using a good welding helmet, okay? Also, if it burns your eyes, it burns your skin, make sure you wear long sleeves on a non-flammable shirt. That would not be nylon. Nylon melts. But leather, cotton duct, jean, denim, all that stuff works really good, okay? And I get it, it's hot. So we're going to talk about TIG. TIG is also known as GTAW. That stands for Gas Tungsten Arc Welding. That's the American Welding Society's fancy nomenclature for saying TIG welding. How many people in here have ever heliarc welded? Truly heliarc welded? One? You've heliarced? Yes. What kind of machine were you using? He says. It
was a Miller.
So you haven't heliarc welded?
I don't have one.
Okay, so well, we're going to go on. What is a heliarc welder? Does anybody know?
Helium?
No, he's pretty close. Back about the time of World War II, we needed a way to try to weld aluminum for our bombers. And the Linde Corporation created or found a way to weld aluminum electrically using helium. And they patented the name heliarc because it was helium in an arc. It was TIG. It's the same thing. So unless you used a Linde machine, it really wasn't heliarc. It was a Miller machine. So it is the same thing, not to confuse you, but people always call it heliarc, or well, I can't heliarc. Well, if you can TIG, you can heliarc. Heliarc is in TIG or GTAW, if you really want to sound like a science guy, it's all the same thing. Now, let's talk. let's talk for a minute about the differences. Does anybody know the difference between TIG and stick and MIG? Shout it out, raise your hand.
Inert gas.
Yes, sir, this man. He, well, thank you for participating and getting a right answer. He said a non-consumable electrode. Okay, that's correct. Those of you guys that are stick or MIG welders, when you're MIG welder, when you squeeze the gun, that wire starts squirting out of the gun, right? That wire is your electrode. It's consumed in the weld process. It's also your filler metal. Stick welding is the same way. We strike an arc, right? The rod starts burning up. Filler metal, electrode. TIG, what's the one thing we don't use? So, some people in here have already tried to practice, I can see. The electrode. How many people have no idea what I'm talking about right now? It's okay if you don't, because that's what you're here for. This is the TIG torch. See that thing sticking out of the end? That's the electrode. Guess what? We don't want to go away. The electrode. It's not consumed in the weld process. As a beginner, you're going to consume a lot of electrode. That's part of learning. Okay? The point here when we weld with this thing, here's what happens. The arc jumps off that electrode down to our plate and creates heat. We put the filler rod in with our hand. It's very, very, very precise. That's why aerospace is almost exclusively TIG welded, because we can control every step of the process. When you MIG or you stick, when you squeeze that trigger or you strike that arc, what you set the machine to over there on the wall is exactly what you get until you stop and go over and make an adjustment. In TIG, it's infinitely a variable on the fly. While we're welding, we're going to use a foot pedal. We're going to adjust that, and we're going to talk about that more here in a minute. So, Andrew Padaka, can you hear me? Andrew? Yeah, it's a bad cord. Andrew Padaka. Ray Canelia. Can you get Andrew Padaka and see if he can fix this for me? I have to hold this so while I talk, and I'll look. Thank you. Yeah. So one of the things, all right, here's what we're going to do. Until he fixes it, I'm done with that. Okay. Thanks a lot. Thanks a lot, Tom Zeleckman. Oh, I project well. Loud. I thought, oh, okay. All right. So,
That little one doesn't work.
huh? The little ones stream into the live stream. Yeah. So, what's the difference between TIG and MIG? Well, we said TIG, MIG, and stick, right? We said that in MIG and in stick, we use the electrode, we consume it. But our welding gas is different too. When we TIG weld, we only TIG weld with an inert gas. So let's take a moment and talk about the welding gases. Inerts. Does anybody know what the inerts are? How many of them are there? Does anybody know? 14 or something? Nope. 6. There's 6 inert gases. Inert, on the periodic table of elements, they're noble gases. What does that mean? They don't react. Yes, sir. They're a non-reactive gas. You already won a prize. I can't give him 2. He's trying hard for another prize. Huh? Hold on. I got it, bud. So non-reactive gas, right? That means it will not form in the weld puddle to make another compound. Like, think of nitrogen, nitrates, nitrides, right? Oxides, if it's got oxygen, we don't want to change the molecular structure of the metal. We want it to stay the way it was. We just want to melt it. So we protect it from the environment, right? We protect it with an inert gas. So we were talking about the inert gases. There's 6 of them. Anybody want to start calling them out what they are? Argon, helium, xenon, neon. Dang, he got the hard one. Radon. There's one more. Nope.
Exxon.
Nope.
Carbon dioxide.
Superman. Krypton. Those are your inerts, your noble gases. They don't want to have anything to do with what's going on around them. Okay, they don't want to combine. So let's talk about the ones we're not going to use. We obviously aren't going to use radon. Why? It's radioactive, so that one's out. Neon, expensive as heck. Get rid of it. Xenon, It works. You can't afford to weld with it though. Xenon, $10,000 a bottle, I've been told. If you guys want to blow some money, you can weld up some really cool project on YouTube using Xenon. Have no idea why you'd want to do that, but it will work. Let's talk about Krypton. It's very expensive too because it's very, very small amounts in our atmosphere. So let's talk about the two that we have left, helium and argon. Those are the two that we're going to use in TIG welding. We'll talk about those two a little bit more in a few minutes. But let's say that we have to use 3 times as much helium at a cost of about 3 times as much as argon. So what's our number one choice most of the time? Argon. Argon, its properties are it's heavier than air. How can that help us? Covers our weld puddle on our weld bench, right? It also is resistant to drafts. So the drafts it could be blowing along, because it's heavier, it doesn't want to blow away as easy. Every kid at the county fair has a helium balloon. Helium wants to go where? Up. And that's why we got to use 3 times as much of it. Plus the wind wants to blow it away really fast because it's really light. And it costs 3 times as much. So helium is not usually our number one choice. Now, helium has a property that we really, really like. Anybody know what that property is? Well, he is correct in a sense, but I just want to correct your verbiage. He said burns hotter. Burns hotter is correct, but helium doesn't burn. We don't burn it, it's not consumable. But when you use helium, it does create a hotter arc. 1.7 times hotter than argon. Anybody know why? It has to do, hold on, we might have an AVE moment here. I'm trying not to because I can't compete with that guy. But it has to do with the excitability of the molecules, the voltage to jump the arc. It doesn't want to flow through helium as well as it does argon. So the voltage has to go up. When the voltage goes up, it creates a hotter arc because it drives the whole principle of the Ohm's law up. Okay? Are we going to try this one more time? I'm trying to save it, my voice, for this afternoon class. Bear with me one. Okay, I'm done. Yep. Yeah, in just a minute, I'll tell you when. Sit down. MIG welders. How many guys in here MIG weld with gas? What do you use? 75-25. Use trimix for stainless. See it straight CO2. Straight CO2 does work. Argon makes it less splattery, but we like to mix the properties of CO2 with argon, and somebody said 75-25. It's sold under a bunch of different trade names because it's all, as AVE says, it's marketing wank. 75-25 is about as honest as it comes. It's 75% argon, 25% CO2. We combine those two gases together to give that weld characteristic something we want. We want the wetting action of the CO2 to allow the puddle to flow in nice. And also, if you've ever welded with it, you'll see that it's not slag, but there's sometimes some stuff on top. And what it helps do is get bad stuff in our weld to float to the top. This isn't a MIG welding class, and I'm not going to go into the specifics of it, but we combine two gases. We never, ever, ever use 75-25 or anything but straight inert gas for TIG welding. TIG is only inert. I always get calls or emails or I can't make this TIG welder work worth of crap because the gas. And it's always the guys trying to use this MIG gas for TIG welding. It doesn't work. Was there a question? It's kind of noisy back there, so I couldn't hear if one of y'all asked a question. Let's talk about torches for a minute. The reason I bring this up about torches is because a lot of people's frustration when you go home and you try to do this, because most of us in are self-motivators, we're self-teachers. We'll watch a guy, we'll go home, we'll try to do it ourselves. Keith Rucker just came to my shop. We're friends, so you guys know that. Keith and I are friends. Keith came to the shop, he said, I got a brand new TIG welder and I'm having trouble and I can't figure it out what it was. One of Keith's problems was his TIG torch. So I'm going to spend a few minutes talking about TIG torches. I brought one here from home just to show you guys. This is a 9 torch. The 9 and the 20 are the same size. The number, don't worry about the 9 or the 20. What it does is it tells you the size of the consumables. This is a fairly small torch The size of the torch typically relates to how much current the torch can handle, okay? Think of oxy-fuel welding. You guys that are oxy-fuel or have used it, small torch tip for a little heat, big old honking torch for a lot of heat. Same thing applies here. Where the problem comes from, if people don't understand there are parts in this torch that are there for a reason and they don't know to look for them when they're missing. Let me talk about that for a minute. This torch has an electrode, and inside here is where the shielding gas comes out, okay? Now, in your photograph on slide number, I think it's slide 10, the parts look a little different, but they're kind of the same, and I'll explain why. Because this is my torch from home off my welder, so I brought it in. I don't have a plethora of torches like when I teach for Lincoln. They have a whole bunch for me to teach with. But I'm going to show you. You see that electrode? This is actually a do-right electrode. Came straight out of the shop. Okay? It is made of tungsten. We're going to spend some time talking about tungsten in a few minutes. Okay? Different kinds of tungsten, but that's the tungsten electrode. It's ground to a point. Those of you that learn to TIG weld the old way by balling your tungsten, don't let this worry you. If you only know to ball your tungsten, you can still ball tungsten. But I can show you a better way. Just like we used to run machines that were as big as this shop to do things, now we have much smaller machines. The inverters and the new tungstens handle the heat where the old ones didn't. Okay? We'll talk about why we ball that tungsten in a few minutes when we talk about AC. So we have the tungsten and a collet. Everybody in here is a machinist, so I don't need to explain the collet. Collet is made of copper and it goes on the tungsten. It is sized appropriately. We get that here. When I teach the aviators, I have to actually explain that part to them. On the front, you'll see something that it's made of copper that looks different than this. This is called a gas lens. I apologize because I didn't have that set up for this torch, but what I did bring is this. So that looks very similar to the collet body that's in your picture. Okay? The collet body goes on the front of the torch like this. It works just like a collet closer. Everybody's familiar with what a collet closer is, or a drawbar? Okay? Collet goes on the front like this. The ceramic cup goes on here. This ceramic cup is made of a high temperature ceramic. It is just like your coffee cup at home. What happens when you drop your coffee cup in your shop? You got to get more coffee. Yes, it breaks. So if you drop this on the floor, it will break. Luckily, they're relatively inexpensive. These are. The FUPA cups and some of the clear cups that all the hot rod guys use, they're very expensive. But these are cheap, like $1 a piece. Now let's talk about these cups. They come in a lot of different sizes. Does anybody have any idea why?
Gas flow.
Gas flow is one, but there's another one. Little tiny parts where you're trying to get way down in the crux, so like say two pipes coming together. If I was using this big fat honking one, do you think I'd be able to get down in there real close? So we go to a small cup. Now there's a number on the cup. But Glenn, I'm dealing with a bunch of machinists and metal workers, so you guys will get that. This is a number 4 cup. Cups are rated in 1/16 of an inch. So a number 4 cup is how big in the hole? 4/16. The hole in the end is 4/16. Okay? Or 1/4. So if it's a 7, it's 7/16. If it's a 9, it's 9/16. And that relates specifically to the different size holes in the cup. This gentleman over here said more gas flow. That is correct. The bigger the hole, the better the gas flow. But the bigger the hole, the harder it is sometimes to get it down into a tight area. That's why we have all these different sizes. Not to be confusing, it's quite simply as simple as a big fire hose versus a garden hose. Sometimes you need a lot of water, sometimes you don't. The big fire hose is a lot harder to move around. The little garden hose is easy to move around. Sit down. So I'm going to take a little break, give you all's mind a little break here for just a minute. One of my sponsors sent a bunch of gifts out for everybody that's in the class. So what we're going to do is I'm going to have my son here start passing out some samples of Osborne Abrasives grinding discs. They sent just a whole bunch of stuff, so he's just going to pass one out to everybody, and when we get done, we'll pass some flap wheels, some hard wheels, some grinding discs. I don't know that everybody's going to get everything, but everybody will get something. They've started to want to sponsor my YouTube channel, and they just said, hey, this is some stuff for everyone to try. I will tell you, this stuff is pretty good stuff. It's made in Germany. I'm pretty impressed with their product overall. Haven't done a ton of it, but I use a lot of flap wheels and a lot of grinder cutoff hard wheels, and they hold up just pretty decent. So take these home and try them. Give one to everybody. One of those, and when you get done, give one of these, okay? Just take one at a time and hand one to everybody. Go on. Go on. All right, so while they're passing those out, let's talk about the way we control our heat. Remember we talked about stick welders and MIG welders. We said we strike the arc, we squeeze the trigger. That whatever that you have the machine set to is exactly what that machine's going to give you, right? If you want to make an adjustment change, that adjustment change has to come from you stopping the weld and coming over here and resetting the machine. Does everybody follow that? When you TIG weld, you have the ability to control your heat on the fly. Okay? On the fly heat change. How do we do that? The most common way, he said foot pedal, and that is correct. The most common way we do that here now, and pretty much in the hobby, professional industry, is with a foot pedal. Does anybody know why we use a foot pedal? What's that? We control the intensity arm, but why do we use the foot pedal to control it? Yeah, but there's another way. There's other ways. We're going to talk about that. How many people walked here today? How many people walked? Okay, one guy that lives down the street. Everybody drove here, right? Everybody is comfortable using that pedal, right? So when you're already trying to learn about a half a dozen other things, holding the torch, getting torch angle correct, getting the right gap between the tungsten and the plate, running your filler metal in, it's a lot easier than something we're already used to. We already do that. Golf cart, car, whatever. That's a very common thing. So it's a lot easier for you to pick up on that skill. This gentleman back here talked about using a hand control. There are hand controls. If you look in this picture, you'll see a hand control. There's dozens of different types of hand controls. There's slides, there's wheels, there's little things that look like tank tracks you can move back and forth. But as those of you have already practiced, and those of you will begin to learn to practice how hard it is to hold your hand perfectly still while you're doing something like this, trying to get your heat to go up and down, and it looks like a bird flew over and did his business when you're welding. Okay, that's what happens. So to keep you from being discouraged, because there's nothing to be discouraged about. None of us made a perfect machine part the first time we ever put something in a lathe or a mill. It took learning and understanding our failures to get better the next time. The same thing is true, and we don't want you to get discouraged when you're practicing your TIG welding. So it's much easier with that foot pedal. Now, while we're talking about foot pedals, I talked about on the video with Keith, a lot of people don't know this. If your machine puts out 200 amps, wherever you set the machine's control, when the pedal is floorboarded, it gives you your maximum amount of heat. Does everybody understand that? So if our machine puts out 200 amps, but on our dial on the front we set it at 100, and we hammer the pedal to the floor like we were driving a top fuel dragster, you're going to get 100 amps out of that pedal. Some guys say, I'm not going to worry about adjusting the machine, I'm just going to set it for 200 and I'm going to use my foot pedal to control the heat. Bad idea. Does anybody know why? Yes, sir, you're dead nuts on. Sensitivity is too high. Think of it this way. Let's go back to the 100 amps. If we set the machine to 100 amps, half of the pedal throw is 50 amps. So a quarter of the pedal throw is 25 amps. And an eighth is 12 amps. But if we did the opposite, if we set it at 200, the little tiny movements start making 15, 20 amp adjustments, especially for welding small material. we just blew that piece of material out. We just turned it into a molten puddle. So you either add sensitivity to the pedal or you take sensitivity away. We always try to practice on a part, a first run we're going to weld anything, something similar material, to make sure that the machine is set correctly. Oh crap, we don't have enough heat, or holy cow, I just made a molten crater on my weld pedal. Then you can go over and make the adjustment to the machine, correct? All right, so this is when we get into the little whiz-bang rocket scientry of welding. We're gonna talk about the electricity involved in the welding. People always ask about AC or DC, which one is which? Keep quiet, please. Keep quiet. AC or DC, which one do I use? So let me simplify it for you, because this was a huge struggle for me forever. If you take all of the weldable alloys, and I say weldable because you have to realize there are certain alloys that cannot be welded. Has anyone ever wondered why they rivet airplane wings on airplanes? In modern science with laser welders and all, why are we still riveting airplane wings on? 2024 aluminum is not a weldable alloy. But what we put in that aluminum alloy to give it its ductility, its extreme strength at a very thin, I mean, think how thin an airplane wing is, the actual cross section, right? And the resistance to corrosion, all the stuff that we put in to make that alloy makes it not weldable. And people always ask, it has to do a lot with copper. There's a lot of copper in it, okay? So we still have to rivet those wings on, but anything that's weldable, let's talk about them for a minute. Steels, all the steels, right? Copper, nickel, brass, bronze, stainless, titanium, Inconel, Hastelloy, Monel, titanium. Did I say titanium? Anybody want to add any more? All of those alloys, except two, are welded in DC electrode negative. We're going to talk about why in a minute, but just in your notes, DC electrode negative. Does anybody know what the two are that we weld in AC? Aluminum, and it has an ugly brother, which somebody already said. Aluminum's ugly brother is magnesium. Does anybody know why? Well, magnesium will burn at a very high temperature, and you cannot extinguish it with water because it burns so hot that it splits the hydrogen and oxygen molecule apart in the water and then burns the hydrogen and makes water again, and it's a repeating process. A lot of people don't know that. Try to put out a Volkswagen Bug that's on fire. I've tried that once. Yeah, these right here. All right, so yeah, it actually, the way you put out magnesium fires is that they're extreme amount of dilution with water to take any of the heat out of it so it can't continue to burn, or you smother it. And it takes a special powder, a powder dry chem. It's a purple K, I think it is. They use it. So let's talk about all of those. All of those alloys. Okay, I'm trying to drive this home because everybody struggles with this. All of those alloys go in one pile, DC electrode negative, except which two go over here to AC? Aluminum and magnesium. Why? Does anybody know why? You're close.
The heat conductivity of the aluminum.
No, he was more on there. He's on it. Aluminum oxide. So let's talk about those things for a minute. This is a piece of mild carbon steel. Just anything you buy from your local steel yard, mild steel. This is a piece of aluminum, right? Would everybody agree there is no parlor tricks here? That this is a relatively clean piece of aluminum. This is a relatively clean piece of steel, right? So would everybody agree that if we took these and we threw them over there in stands, bushes, and next year at Bar Z, that we come back and look at these two pieces, they've been there all year, that this is pretty much going to look the same? Would we agree? Will this look the same? Why? Oxide. But why does this look the same? Yes, sir. You got it back there. It's already oxide. So we agree that this is a relatively clean piece of steel, right? This is a stainless steel wire brush. It's a brand new one. There's no parlor tricks here, okay? I want to show you about the aluminum oxide. Can everybody see I'm just brushing it? You see that? That's the aluminum oxide coming off. Now here's a couple of facts about aluminum and aluminum oxide. Aluminum oxidizes almost instantaneously in the presence of our atmosphere. That oxide layer, aluminum oxide, is what we bake our grinding wheels out of, a lot of them. It's extremely hard, second I believe only to diamond. And yes, zirconia is a diamond. Don't tell me that it falls in the chart below zirconia, because zirconia is a diamond, okay? Extremely hard. Melts at a very high temperature. Anybody know what aluminum oxide melts at?
3600.
Yes, sir. Thank you. I bet you watched it. That's amazing. Not many people know that. 3,600 degrees. So let's compare 3,600 degrees. Just pure aluminum melts at around 1,200. So we melt the aluminum, but it's encased in this aluminum oxide, right? What happens to this piece if we just tried to melt it without taking the aluminum oxide off it? Oh, you'll put a hole in it. How many people in here, because I know there's at least a half a dozen people, have just melted a piece of aluminum with like a torch to see what happened? There we go, all right? You notice that it looked like a pie when it started to melt, and there was like a crust on top of it? That crust is the aluminum oxide because it didn't melt. It takes 3,600 degrees. At about 3,600 degrees, the aluminum's already boiling off. So what good does it make, right? We just turned our part into a molten puddle. How do we get it off there? Well, I showed you that with a stainless steel wire brush, we could brush it right off, right? The problem is that we brushed it off, and before we could even pick the TIG torch up, it's already started to oxidize again. Same pie crust effect again. How do we get that aluminum oxide off there? Yes, sir, he said the AC. The AC sine wave, if you've ever seen one on an oscilloscope, goes up and down like this. That AC sine wave will blast the oxide layer off the aluminum, and when it blasts it off, why doesn't it oxidize back? The inert shielding gas keeps the atmosphere away so no oxygen can get to it, right? So now we can make that weld, but why do we like that oxide layer? There's something about that oxide layer, we don't care if it oxidizes when we're done welding it. Why? Absolutely, dead nuts on. Protection. That's why this piece in the bushes next year is going to look like this, because that oxide layer is clear, hard, and almost impermeable and self-healing. Think of a lawn chair out on Stan's pool deck. You drag the aluminum lawn chair across the pool deck, you just scratch all the aluminum oxide off it. But it starts healing itself almost immediately. It's like having a can of Krylon to protect it, right? So it protects itself. That's why we like this stuff for marine use. Because if it gets banged up and scratched, it automatically starts to oxidize and protect itself again. Now, I realize if it's a salt environment, the chlorine is very caustic, the chloride in salt, we anodize, we do a lot of stuff, but we're fundamentals here, okay? So we take that oxide layer off with the AC. The only two that oxidize like that are a magnesium and aluminum. That's why those are the only two we weld in AC. Everything else, I'm saying this again because people get confused. DC electrode negative. Remember, it's got to be electrode negative. And we're going to explain to you. I'm going to explain to you why. Right, have you guys gone through everybody?
No, we still have to do these, the last ones.
Okay.
The last set.
Okay. Oh, I thought I was going to have to do it from memory, and that's a scary place. Let's go to the very first slide, which is slide number 10. You guys see this picture? This picture right here? This is a picture of the TIG torch up close and the electron exchange that happens when your electrode is DC, when your electrode is negative. So let's talk about that for a minute. Think of a battery. It doesn't matter what battery it is. Your cell phone, your car, smoke detector at home, all batteries are DC regardless. There is no such thing as an AC battery. All batteries are DC. DC stands for direct current. There is a direct and constant flow of current until the battery is depleted or you turn your cell phone off. Okay? Once you make a demand, it is a constant flow. The electrons never change the direction they flow, so you have a positive and a negative. If this is our TIG torch, our tungsten, we make it negative. That's why we call it DC electrode negative. Here's the remarkable thing. You might want to click your pen and get ready to write for this. I realize there's a lot of guys out here that are very Google and scientifically oriented, understand the number I'm going to give you is for easy math in your head. You'll understand why in a minute. Measured at the center of the arc is about 10,000 degrees. Okay? Center of the arc, about 10,000 degrees. 70% of the heat when you're DC electrode negative is in the plate. So if we make a 10,000 degree arc, how hot is the plate? We're putting 7,000 degrees of heat into the plate. Now realize that plate's dissipating heat rapidly. But that's where our molten puddle comes from. How hot is the tungsten, the electrode? 30% of the heat is, I'm sorry, I don't know if it's 3,000 degrees, because 30% of that heat is in the electrode. So it's 3,000 degrees. Write this number down if you're taking notes. 6,280 degrees. At 6,280 degrees, pure tungsten melts. So we got 30% of the heat going into our tungsten, right? How hot is our tungsten? 3,000. Did our tungsten melt? No. So the tungsten's good to go, right? Go to slide 11. Remember our battery? We switched the positive and negative on our battery. Let's pretend like we made the tungsten positive for a minute. Same 10,000 degree arc, but now 70% of the heat is in the tungsten. How hot is it? Stay with me. So the tungsten's 7,000 degrees. What temperature does pure tungsten melt at? So what happened to the tungsten? It melted. Those of you, and I'm only going to say this, the rest of you that have never done it, don't worry about it. Those of you that ball tungstens, that's why you go to positive, step on the pedal, and ball the tungsten. It burp, starts to melt, and it makes your ball. Okay? So you're going to ask, well, why would you even put that in a welding machine? Because I get that question all the time, right? A TIG welder is what's called a constant current machine, meaning that it monitors current and it keeps that current at a constant level. Let's just say you're going over to your stick welder, right? Stick welder, constant current machine as well. Stick welder, 90 amps, clip the electrode, strike the arc, right? You're burning rod, fixing your farm equipment or whatever you're working on, you're burning rod. If you have it set at 90 amps is what that machine's going to give you regardless of what happens. If you long arc it, short arc it, it varies the voltage, not the current. It is a constant current machine. Go to the TIG welder. TIG welder, wherever we tell that thing with our foot pedal where we want it to hold the heat, it holds the current constant. Also a constant current machine. So every TIG welder is also a stick welder. All we do is take a stick welder and we give it the high frequency start, which we haven't talked about yet, to get the arc started, to get the arc established, control gas flow. And a stick welder can TIG weld. Okay? Constant current machine. So why do we put a positive on there? Anybody know?
Shallow penetration.
We stick well with electrode positive. We stick well with electrode positive, so if we just allow you to change the leads around and go opposite, you can stick a stick stinger in there. They can't hear? The mic quit working. Andrew tried to fix it, but it didn't. I'm doing my best I can, guys. I'm sorry. So we stick well with electrode positive, so just by switching that, taking the TIG torch out, ground over, and putting a stick stinger where the TIG torch went, now your machine's now a stick welder. And those of you that have a machine or have used a machine at home know that there's a switch on the front that'll say stick TIG. And all that does is take it looks for high frequency pedal control to start the arc. It takes it and gives it to the stick stinger. Okay? Simple circuitry to change it. Everybody with me on that so far? All right, let's talk about AC. Remember that sine wave we talked about before? AC, what is AC? AC is alternating current. That means that the positive and negative switch back and forth rapidly. In the United States and most of Europe, if you look at any appliance that plugs in the wall, it'll say the voltage, 120 volts, like if we have a blender here in the US. On the back of the blender, it says 120 volts, 60 hertz. 60 hertz in the United States is almost exclusive. There's some parts of Europe that are 50 hertz. Doesn't make any difference for our application, but to understand what that means, it means that positive and negative 60 times per second switch back and forth. I think it's in the cord over here, Andrew. Every now and then when I wiggle the cord, it shuts off. 60 times a second in the US, it switches back and forth, okay, on the AC. So when you look at this sine wave, understand that this line here is 0. There's nothing happening. As we see that sine wave go up, the voltage is increasing as well as current flow. As we go down back through 0, nothing happens right here. Nothing happens right here, but then our polarity switches because now we're going down towards the negative. If I didn't say it, sorry, I'm a little distracted. Positive, negative. We're positive, now we go down through 0, we're now negative again. So our electrode became negative, and all of a sudden we're putting on a negative. When did I tell you that all of the heat got into the plate? When the electrode was negative. Negative. 70% of the heat is in the negative. So right now, how hot is the plate? Plate's the work, what we're welding. How hot is it? Somebody tell me. We're putting 7,000 degrees of heat. But when we switch backwards and we go to positive, now we're going back to the positive side of the cycle. On the positive side of the cycle, how hot is the plate then? 7,000, we're positive. We're switching back, I'm sorry, you're right. I said plate, you're right. I caught myself, thank you for the clarification. The plate is 3,000, how hot is the tungsten? 7,000. So we're splitting that heat between the tungsten and the plate. So 50% of 10,000 is? So how hot is the tungsten? 5,000 degrees. What temperature does tungsten melt at? That's why we can weld in AC with a tungsten and not melt it. Okay? Because we're only going to put half of that heat in there, which is about 5,000 degrees. And the tungsten can handle the heat. Okay? Any questions on that? Let's talk about a little bit about balance control on the machines. How is it? What does it do? Why for? Where they're, and why not? This is considered a sinusoidal AC sine wave. It's also called a lazy sine wave because it is at peak output, very little amount of time. Right? Can you guys see that? It's only putting out its maximum output very short. The rest of the time, it's either deciding it's going to work or deciding when it's going to go take a nap. Right? Think of it that way. It's a lazy sine wave. So the engineers figured out, when do we need most of the heat? To melt our plate, right? To melt our work, whatever we're melting. So what if we could spend less time being positive, because all we need is the electrons to pop out for a second to blow that oxide layer off. And when you TIG weld aluminum, you can actually see it coming off with your naked eye. You can see the little flakes coming off of it. Okay? That's what that AC sine wave does on the positive side. We don't do any work, we waste the heat. We put it into our torch and we got to cool the torch off, right? Got to keep the torch cool. That's wasted work. So if we could spend more time being negative, that means we spend more work. That's what balance control is. If you weld with a TIG welder that has balance control or auto balance, what the machine is doing, if you look at slide number 15, what your machine is doing, look at the bottom picture. It's spending less time positive and more time negative. Now what if we had some really crappy material, really dirty material that for one reason or another, we couldn't get clean? If you have an adjustment and you turn it so it spends more time positive, what happens? I'm looking for a word. More cleaning. That's what balance control does. It allows you to change from the cleaning side to the penetration side. Now remember, a minute ago we talked about helium, the 1.7 times hotter with using helium gas. All right guys, this is where we put on your thinking caps, critical thinking. Big, thick old cylinder head, intake manifold, big old slug of steel on some aluminum on some machine. Aluminum is highly thermally conductive, likes to rip heat away. Think of the back of your big amplifiers, your CB radios, all that stuff. Those fins that are on the back, they're all to get the heat off the power transistors. The power transistors don't like heat. Because it likes to give heat away really rapidly is the reason we use it for that. But it sucks when we try to weld it because it's trying to get rid of the heat as fast as we're welding it. So that big, thick piece of material, we switch our welding gas, then we take our balance control and switch it more to negative, right? We took that same, you wonder how those machines are getting smaller and smaller and smaller? Because we're learning to control where we put where we put the energy. Now we can switch it, put more negative, switch to that helium, got 1.7 times more heat out of using helium, and we can make that same weld with a small machine we could have never done ever before in years past. Is it starting to come together? I know there's a lot of distractions going on with everybody popping in and popping out. I apologize for that. Let's talk about frequency. Some of the machines have frequency control. Remember I said in the US and most of Europe, they have 60 hertz, right? 60 hertz sine wave. That means a positive and negative switch back and forth 60 times a second. So 60 times a second, you get a cleaning action, right? You're popping those oxides off, cleaning them, cleaning them, cleaning them. What also happens, when we increase our frequency from 60 to say double, 120 hertz, so 120 times a second, we also are able to focus our heat down in a smaller area. So we're changing the number of times we clean. So which is better, to clean half as much but harder, or to clean twice as often and less hard? Right. If we up the frequency, spend a little more time on the negative doing our work, we're still doing the same amount of cleaning, but we're spending less time hanging up on the positive. We can also focus that heat exactly where we want it. And if you've ever wondered how those guys in aluminum get those little tiny, little itty bitty beautiful TIG welds like on an aircraft, they're typically running a higher frequency. Okay, I want to stop that for just a second and I want to talk about tungsten. This is not part of the regular class that I teach, but a lot of people have started to ask a lot of questions about tungsten. Those of you who don't know, there is a color coding for tungsten. In your handout, you can go to 18. Is that got the color coding chart on? 18. There's a color coding chart on 18. There's a lot of different types of tungsten alloys out there. We were talking a little bit earlier with this gentleman over here about balling tungsten. When we used to teach you the green tungsten, you ball green tungsten. I have green tungsten at home, and the only reason I won't throw it out is because I'm cheap. I will never ever in my lifetime use green tungsten again for anything other than maybe making some kind of weird cutting fixture for the lathe or something. Okay? Do you see, can you guys in the back see that? The colors, do the colors show up at all? How about that? Can you see the colors? You don't really need to see what the colors are, but you need to know there's a color band on there. What these are doesn't really matter. This is how we identify the different kinds of tungsten. When you get a brand new tungsten, it's going to look like this. No, it's not going to look like that one. It's going to look like this one. Okay? It's blunt on both ends, and it's got a color band, if you can see the red. Hopefully you guys can see the red showing up. I can tell you this is a 2% thoriated tungsten. State of California, you can't even have a 2% thoriated tungsten anymore. Along with fresh drinking water, it causes cancer. Does anybody know why? We'll just talk about it for a minute. Thorium, pure thorium. Anybody know what you use thorium in? A little bit, yeah. But besides medical research, there's people in here with thorium with them right now.
It's radioactive.
It is radioactive. If it's radioactive, it means it does what at night? Luminescent watch dials on the real expensive dive watches. Yeah, but a lot of people still have their granddad's watch, and you know they're still wearing it. Their old marine, the old marine watches had it in it. Okay, it's thorium. What's in here is not thorium. It's a misconception. It is a, what does Trump call it? Fake media or fake news? It's thorium oxide. It's not thorium. But anything related to thorium, everybody is scared about causing cancer. Because a bunch of people yeah, right. No, it is not radioactive. I flew here with this in my bag. If it was radioactive, I'm pretty sure I would have been like the guy in, what was it, the movie, scare movie, Monsters University, when they put the hood over and when they shot it to the ground and they bonk and they fried all his hair off. That would be me. It is not radioactive, okay? Some folks got cancer and they related it back to these tungstens, and I'll tell you my opinion. This is an opinion. It is not the thorium. This is a heavy metal. All of these tungstens are heavy metal. If you grind the heavy metal and breathe the dust, it's bad juju. If you spend all day working in a laboratory sharpening tungstens without proper ventilation, that could be bad, right? Everybody understands that? So, well, good ventilation, get your head away from any dust that could be coming out of this. Everybody get that. These color bands tell what these tungstens are made out of. It gets very confusing to the beginning welder. So let me try to clarify this for you. We've had a lot of changes. This is a brand new color code chart that just came out, and I heard there's going to be another revision to that. Okay? And I can explain to you why. I'll tell you what, if you guys want to know afterwards, come up here, I'll explain to you why they changed the color code chart. 2% thorium oxide they can't sell in the state of California. Well, I live in Florida. That's where this one came from. And it'll go home with me. Okay? Gladly. These things work great. Used them forever. Still use them. They're getting harder and harder to get because the industry is shifting away. They're going to, I think they call it, it's not purple. What do they call it? Violet? My wife will tell you, I think, in primary colors. So it's purple. It's not violet. It's purple. It's also not chartreuse. It's neon green to me. But whatever, right? There's another color called chartreuse. These are new alloys they've come out with. Thank you, Andrew. We're going to try this one more time. Can you turn it up just a little bit? I know you guys in the back are struggling. I'm sorry. I'm going to try this one more time. Okay? No mic drop. Okay? The thorium oxide won't hurt you. The purples don't have any thorium oxide in it. They use zirconium, ypnium. I forget. It's a non-radioactive material, not related to anything radioactive. And I will tell you that the purples, which are actually called violet on that chart, the violets work really well too. So, going around my ass to get to my elbow, so to speak. But don't let it confuse you. If you guys are beginning, I recommend using the chartreuses or the purples. They work really good. But let's talk about the diameters for just a minute. Everyone says, I'm getting a new welding machine. I want to go to the welding supply and buy everything that I need so that I have it in my shop. What do I need? For most practical purposes in our shop, unless you guys are doing aerospace, really small stuff, or you're doing some crazy, really thick stuff, like over 3/8 of an inch, a 332 tungsten gets it done every time. The weld shop will love to sell you collets and gas lenses and all the stuff and tungstens all day long. But I can tell you that for most of applications, a 332. If a guy wanted a pretty well-equipped shop, a 332 tungsten and a 1/16 tungsten is your go-to. Okay? Does that clarify it? Okay? Because everyone's like, I don't understand. I blue, purple, chartreuse. Get you a purple or a chartreuse 332 and a 1/16 and learn from there. The weld supply can give you a little bit of direction on that. Now, let's talk about the diameter of the tungsten. What does anybody know why the diameter matters? Heat. He said heat. That is correct. But why, when we go to a thin tungsten, why is it important? Or I'm sorry, when we go thin material, why do we want a thin tungsten? Does anybody know? There's actually a reason. It would be smaller cross section, but there's even another point like that. How many people in here have at least dabbled in TIG welding? Okay, those of you that ever started, When you started your arc, first time on the plate, you ever notice the arc wander around for a second before you really came on the puddle? Do you know why it does that? Nope, it's not the grind. Every time when everything's cold and you step on that pedal for a minute, if you don't just hammer the pedal but you roll into it, you'll see the arc kind of come off to the side and kind of wander around the tungsten. Then all of a sudden it'll come on, and it'll come on. You'll have a real good arc. It's heat. It's heat. It's heat. Tungsten likes to emit electrons at a specific heat above a certain temperature. So if we're using very, very low current, think aerospace now. Think we're going to be really cool right on Instagram and show everybody how we can weld aluminum foil together. If you had a TIG welder, I'll show you. It's a parlor trick. It's not hard. My 9-year-old could do it. It's a parlor trick. But let's think we're doing something for real. We want to weld this part. And you're trying to weld at 12 amps. That 332 tungsten never gets hot enough to give you a very stable arc. And somebody else said about the smaller point, the smaller cross section. We grind that 1/16 tungsten down. It gives us a very, very fine point for the electrons to come off. But the electrons always run to the tip and come off. Which brings up my next point, grinding tungsten. I only tell you this because it was one of my struggles in life and nobody taught me this. Well, eventually they did. Okay. That's our red tungsten. If you get it, it's blunt-ended on both ends. You have to prepare that tungsten to use it in your TIG torch. You will do it with a grinder. There is a specific way to grind tungsten. I did not know this. That's why I included it in my lecture. If you do it the wrong way, it makes you say a lot of bad words, usually in strings. Okay? Yeah. Yes. Realize anytime we grind, it puts scratch marks. We all get that as machinists, right? So what we want the scratch marks to do, this is a point, just like a pencil point, and you guys can come up here afterwards and feel free to look at it, okay? We want all the scratch marks to go to the point, okay? So if this is our grinding wheel, think of a bench grinder, we want to hold it like this, okay? All the scratch marks go in a linear fashion. The reason is electrons only flow on the outside of metal. We would think, okay, I'm going to have a whole bunch of current, I'm going to have a big fat wire, right? We've got to go bigger wire. It's not the thickness of the wire that matters, it's the circumference of the wire that the electrons flow over. That's why stranded wire can be smaller in physical size and still carry more electrons because there's more surface area, okay? Electrons go down the surface, they hit those little scratch marks and they go straight to the tip and jump off. If you do it like my pop would have done it, if I took this, my pop's like 82, I say, hey Pop, go over to the grinder and sharpen that for me. He'll go over to the grinder. I guarantee you right now, I bet money on it, I bet a $20 bill on it right now if he was here. Fire up that grinder, he'd go right to the side of the grinding wheel and he'd sharpen it for me. Those are circumferential scratch marks. The electrons come right down to the first scratch mark and they jump off to the sides. They won't come to the tip and it looks like an umbrella. That's exactly, and you can put no heat down on your point. And you start saying bad words in rows and columns. Why in the heckity heck, blinkety blank, would this not do what I want it to do? And it's as simple as grinding it incorrectly. Now people ask about grinding, what do I grind it with? And everybody likes to buy the really cool stuff. Diamond wheels are the best. They're expensive. You know what I use? An aluminum oxide grinding wheel from not Harbor Freight. But seriously, whatever came on the grinder is what I use. I use an aluminum oxide grinding wheel. They make silica carbide grinding, the green ones, all of that ceramic, they all work great. But for the home hobbyist, unless you're welding aerospace type stuff, aluminum oxide works fine. The one thing I will tell you, the grinding wheel that you use to grind tungsten is for tungsten only. You don't want to go grind something and then grind this because it puts the impurities in here. Everybody follow that? And then it becomes 7,000 degrees and jumps off across your weld, and then that's a discontinuity and that's where the crack starts.
It does make pretty designs with it.
Yeah, it does. It does. So grinding, people talk about it all the time. I don't feel comfortable grinding on my pedestal grinder this way because it's going to get stuck in the wheel, and then if you're a gentleman, where is it going to wind up, right? Okay, whatever. So then they say, can I grind it this way? Absolutely. There's no reason why you can't hold it this way, and then it goes into the guard and around and comes out with the point sticking out, and you follow what I'm saying, right?
It's stuck to the wall.
Right. It doesn't matter, it's gonna hurt anyway. My point is, yes, as long as the circumferential scratch marks go to the point, doesn't matter. We don't want to go to the side of the wheel. Belt sanders, people ask, can you use a belt sander? Sure. There's no reason you can't. A little trick to get a nice pretty point on it. Chuck it in your drill and spin it slowly while you're grinding it. And there's some shop teacher somewhere that's cringing right now because I told you that. Because you can spend a ton of money on a tungsten grinder, hundreds and hundreds and hundreds of dollars, and you really don't need it. Unless you're learning, and then you'll be like, man, I really wish I had a tungsten grinder. I've sharpened this 17 times in the last 15 minutes. Let's talk about filler metals for a minute. And I think we'll wrap this up. Filler metals. Yes, sir. Does grit size actually matter? For the beginner, I'm going to say no. The finer you can get the grit, the more polished that end will look, and you'll get a prettier arc. But I'm telling you, you're going to put the hood down with a brand new tungsten in it, strike an arc, and weld about that much, and then you're going to throw the thing down. Dang it, I just messed it up again. You're going to spend all that time with a fine wheel trying to take an extremely hard material. You've got to grind all that off there. So yeah, in the shop, they actually polish tungsten in the aerospace shops. They actually polish them. That's how important it is. But for us, it doesn't matter what we're doing. For anything outside aerospace, I don't think it matters. A medium's what I have, and I use in my shop. Filler metals. Everyone asks, what do I use for a filler metal for aluminum? What's your go-to filler metal? Does anybody know the answer to that question?
4043.
4043. Very common. It's probably my go-to most of the time. How about 5356? Okay, those are the two go-tos. Two things. If any of you know what we're talking about, filler metal for tungsten, or I'm sorry, filler metal for TIG welding. It's hand-fed. Okay, aluminum has some specific ones that are very common. 43 and 5356. I'm going to tell you these if you're a note taker. If you're going to go home and start doing this and you want to make parts and anodize them, don't make the mistake of welding them with 4043 filler metal. I have a friend in Florida who built his own T-top for his boat and welded the rocket launchers, you know, that hold the poles up on the T-top, sent it off to being anodized. It came back and every one of those welds wasn't anodized. Anodizing will not stick to 4043 because of the high silica and the 4043 filler, but it works good for a lot of stuff, okay? You have to use 5356, but that's just for you guys that are note taking and want to look into that, okay? I'm gonna make this really easy for you. All the work is already done, 100% of the work. Go to Google. Everybody here has Google, right? Type in aluminum alloy chart. There's gonna be like 1,000 hits. Very first one's typically Alcoa aluminum because they're a big manufacturer of aluminum. Aluminum alloy chart, Alcoa aluminum, go to it and look at what you're welding. If you don't know, don't weld it until you know. If you're guessing, usually you can get pretty close with guessing. If it's an important part, let me back that up. If it's an important part, do not weld it till you know. Some filler metals don't coalesce with the parent metals, okay? There are 7,000 spaces on the aluminum alloy chart. You can't memorize it all. 4043 and 5356 are usually the go-to for a lot of guys. There's nothing wrong with that. But if it's your garbage can toter, taking your garbage cans out the street, who cares if the wheel falls off it? If it's the wing on an airplane, it's a lot more important. You understand what I'm saying here? It's got to be relative, okay? But all of the work for figuring out is done for you. If you buy goods, if it's a 7,000 T6, 60, 61 T6, 50, 52 sheet, whatever it is, if you buy that stuff from your yard, they're going to be able to tell you. You go right in 50, 52, it'll say number 1, number 2, number 3 choice. All the work's already done. You don't have to guess. Any other questions? Besides, it's okay, you can give me dumb looks. You guys are already experts. Oh, I use all my scraps. I got a 9-year-old that's wanting to TIG weld now, so it's getting real expensive.
Use your scraps as the filler rod.
So, hang on one second, let me answer this. He said use your scraps as the filler rod. Bad idea, and let me tell you why. What you don't realize is that filler metal has certain elemental compounds in it, like in the instance we were just talking about, the 4043 filler for aluminum, a lot of silica. That's why a lot of guys use it for cast. They like it for cast. High amount of silica in it. Guess what your base metal doesn't have in it? And that helps with the puddle control, flow in and out, getting the impurities to flow top, a whole bunch of metallurgical science. And be honest with you, I don't even understand all of it. I understand a lot of it, but not all of it. The filler rod is designed to be filler rod because it wants to aid in the joining together of the two materials. We are going to have a fight this afternoon. All right, you had a question, sir.
What's the relationship between the thickness of your base material and your filler rod?
You ask what the relationship between the base material and the filler rod. So think of filler rod. All right, let me back up. Okay, he asked about the thickness, diameter of the filler rod. The filler rod comes in different diameters. So if we want to put a lot of material down fast, we're going to use a big rod. But it doesn't make sense to use a big rod, and I'm going to answer this with a kind of an analogy. How many people are MIG welders in here again? Have you guys ever tried to use your MIG welder on sheet metal, like body sheet metal? I notice you just keep poking holes through it. Do you know why? I'm going to answer, you're going to go, holy crap, why didn't I never think of this? You're using 035 wire and it's an 024 panel. 020 panel, whatever the panel was made out of. The filler metal is thicker than the panel, so which one's going to melt first? The panel, and it's going to poke a hole right through it. So going back to your question, you would not use a 332 tungsten if I was doing an 035 piece of material because it takes more heat to melt the filler material than it does when the base metal. Does that help a little bit? Let's say that I've got a big, heavy weldment of some kind. I've got to put a lot of filler in there. I wouldn't want to use a 1/16 or a 40,000th filler because I'd have to put the whole box of filler in it to fill it up, right? So you got to kind of think about your heat. What's it going to take to melt that filler rod? Because that filler rod a lot of times can be thicker than what you're actually trying to weld. Anything else? Yes, sir.
So, I have a friend who's learning how to weld.
Okay.
And he constantly dips the wire under the electrode.
Uh-huh.
How much electrode do you have to grind back? Do you have to just grind a pressure tip, or do you have to grind all that to
That's a $64 million question. His question was this: I have a friend who is learning to weld, and he keeps correct me if I'm wrong, he keeps dipping the tungsten into the puddle. And then he's got to go grind the tungsten back, correct? How much of it do I have to grind back? Till you get to clean tungsten, uncorrupted tungsten. Because once the tungsten is corrupted, anything that's in that tungsten other than tungsten begins to emit off. And it gets in your weld puddle. That creates what's called a discontinuity, and that's where your crack starts to form right there under stress. Because, and we'll take a minute to talk about that because I didn't cover it. Aluminum. Aluminum needs to be clean to weld it. And I'm going to give you three little hints to welding aluminum. You can write them down if you want. The very first step, welding aluminum is clean it. The second hint to welding aluminum well is clean it again. Anybody know what number 3 is? Clean it again. Aluminum likes to be clean. How do we clean aluminum? Stainless steel wire brush, $64 million question. Does anybody know why we only use a stainless steel wire brush? On it again. Doesn't oxidize. Let's think about our wire brush for a minute. This is a really nice Osborne wire brush they sent as a sample. It is a carbon steel wire brush. Great for rust on ferrous metals, all kinds of stuff, right? Not great for aluminum. These bristles, even though they look brand new, if you look them under a microscope, because they're carbon steel, they have rust on them. Okay? We go start brushing the aluminum with this thing, that flakes off. And then aluminum's soft. We put scratch marks in it, so we scratch it down into the aluminum. Then we come make a molten puddle out of it, and we encase that iron oxide in the aluminum. That's called a discontinuity. And what starts at a discontinuity? The crack. Stainless steel doesn't do that. However, what do we not do with our wire brush if we're using it for aluminum?
Is it for anything else?
Like cleaning the grill. Not that that's ever happened in our family. Also, you can use, there are commercial products, and All Clean is one of them. It's a brand name, but it's basically mild phosphoric acid. It helps get a lot of the oxide stuff off it. What you need, Tom?
There's a question.
Okay, go ahead. Tom's got a question from the live stream.
Yeah, so Dave Cross was asking a question, how do you determine the flow rate?
How do you determine the flow rate? I assume he means argon or his shielding gas. So it's the question they're asking is how much gas do I put out of my TIG torch? Well, let me give you a couple of rules of thumb. For argon, it's about 15 to 30 cubic feet per hour, which you're going to have a gauge or a flow meter on the side of your regulator on your tank. 15 to 30. Helium is 30 to 60. Okay. How do you know was the correct question? Well, the way you know is if your weld doesn't look right, you probably need a little more gas up to that point. I'm cheap, so I turn that thing down as low as I can get it and still get good gas coverage because I'm trying to double the amount of welding I can get done out of my bottle. But if you're in a drafty situation or a situation that you're just not getting good coverage, crank it up to a point. Realize they gave you a range, right? What happens is say you tried to crank that thing up to 100 cubic feet per hour. Wind blowing, I'll just crank her up. You spray gas out of there at such a violent rate it begins to whip, and as it whips the atmosphere in with it. Think of a blender. You start pulling that atmosphere in there. So that's why there's that range. That range you're still safe in there. Another question. Did I answer your question? Yes, sir.
Take over MIG for aluminum. Is it really worth the more expensive machine?
I'm teaching you a TIG welding class, aren't I? Yeah, his question was TIG over MIG for aluminum. Is it worth spending the money on the more expensive machine? TIG is known for one thing, precision and high quality welds. It's not known for speed. If you're trying to do production work, say you're making aluminum trailers, wouldn't be my first choice because your time is money and your time is spent welding. That's when I would spend the money. I have a Python push-pull gun on a C300. I was making a bunch of tanks, aluminum tanks, 10 feet by 10 feet by 6 feet high, tons of seams and all stuff. The machine paid for itself in the first tank because it's haul ass fast. It's MIG fast, but it looks like a TIG weld. But you're talking about a $10,000 machine. You know what I'm saying? So did I answer the question for you? Any other questions? You got anything on your end, Tom?
That's good. Actually, I've gotten a lot of compliments, so I don't necessarily want to tell you that.
Am I? Really?
I know. I mean,
God gifted me with a big head.
helmets only get so big.
I have trouble buying hats. Anything else, folks? Yes, sir, in the back. How do I hold my torch? Oh, dadgummit, it's all taken apart. Give me just a second. I want to tell you guys one thing. I left this out because we got distracted with the handing out. On the back of this is the back cap for the torch, and I forgot to add this in here. You see that goes in there like that? There is an O-ring. Do you see that there is no O-ring on that? Do you know why this torch isn't on at home anymore on the back of my TIG torch? Because I couldn't figure out why it wouldn't weld worth a crap, so I put another torch head on there, and I forgot to check that. It's a little O-ring. What that O-ring does is keep the argon inside here and coming out the front. And without that O-ring, it starts, Venturi effect starts pulling atmosphere in. And all my welds look like garbage. And I was like, okay, let's stop here and start troubleshooting. So it's a whole lot easier, or not really, but I was like, I got another torch right there. I just put it on there and started welding. And then a little while later, I go, oh, I need a long back cap, and I took it off. Crap. What happens is these torches get hot. When you unscrew it, it comes out of this rubber casting. A lot of times the little O-ring rolls off and falls on the floor. It's like a 4-cent O-ring. I have extras. I just didn't realize it because I was not doing my job very well at that moment. I was probably actually disciplining kids at that moment because my kids grew up in the shops or something. Don't touch that. Don't turn that on. Stop touching your brother. Somebody asked about TIG torch, angle. Can everybody see this? I hold, if you mean this grip or this grip or this grip, I hold it however it's comfortable. The key to making good TIG welds is being comfortable. There is no shame in stacking up wooden blocks, cement blocks, jack stands, whatever you have to get comfortable to make that weld. These guys on Instagram that do the walk in the cup and they're standing there and lift their helmet and drink a soda while they're doing it, I don't care how you weld it. I mean, you look cool and you're an impressive welder, but we care about how we make welds, right? And whether they're good welds. And you won't make good welds if you're not comfortable, because you're constantly thinking about, wow, that hurts, or I'm uncomfortable in my back, my arm, that's burning me. How many people have been like, I'm almost done. My shirt's on fire, but I'm almost done. I have done that more than once, right? So, however it's comfortable. There's nothing wrong with holding this TIG torch like that if you have to, if it's comfortable and you can make a good weld. Typically, the way I hold my TIG torch is like this. Torch angle is extremely important. Okay, let's talk about that for 1 second. 90 degrees to the plate. So you see that if the plate was laying here like this, 90 degrees, right, in our direction of travel. We're allowed a 15 to 20 degree back angle in direction of travel. Every beginner does this. Guys, listen to me, because you're going to catch yourself. Why does my weld look so bad? Because you did this. Because you want to see what's going on under that gas, and you put your head down. I mean, you didn't put your head down. 90 degrees to the plate, 15 to 20 degree in the direction of travel. Okay? What it does is gives cast coverage out in front of your weld just a little bit. Why? Does anybody know why? Heat, but yes, but gas coverage. Well, sort of, yes. Filler rod. As we pull the filler rod out of the puddle, it's molten on the end of the rod. So that little bit of back angle puts a little bit of argon out and gives that a second to freeze so that it doesn't pick up contamination for the atmosphere. And ideally, you should be keeping that filler rod right in that plume the whole time. Not everybody does it as a beginner, and I get that. This isn't an advanced class. This is a beginner class. So 90 degrees, direction of the travel. 90 degrees, 15 degrees back in the direction of travel. Does that help you? Did that answer your question? Anything else? Good? Everybody, thanks for coming, everybody. We'll try to do it again. Hey, don't forget, subscribe. That's the word of the day, subscribe.
Don't skip ads.
Yeah, don't skip ads. Sure.
How you doing? Pleasure.
You need that? Hi, everybody.
All right, folks. Just a second. Let's switch angles here. Okay, so for everybody who's on the session, we're getting ready to change things up. As I told you earlier, Stan has requested that we break the live stream up into chunks. So we're getting ready to move things around and get things going. So time for a different view, different venue. We'll be back shortly. Don't forget, we have a different link for the stream. So go back to Stan's channel. So it's Shadon HKW. All right, go back to the channel and you'll see the next session. So what we'll be in is the 10 to 12 session, even though everything's off, by a little bit. And we'll be kicking it off there in just a couple minutes. So see you soon.